Hello students, in our chapter rational and irrational numbers, we have learned about rational numbers. We have studied how to show rational numbers on number line. Also, we have studied how to compare rational numbers. Also, I have studied the decimal representation of rational numbers. Now, in this chapter, the next topic is irrational number. Now we are going to learn about irrational numbers and how to show irrational number on number line. For example, root 2. Root 2 is irrational number because the decimal form of root 2 is non-terminating and non-recurring. Non-terminating and non-recurring. That is why root 2 is irrational number. Now, how to show this number on number line we will see in this topic. Now we will learn how to show irrational number root 2 on number line. So this is number line. From 0 to 1 this is 1 unit distance. So here coordinate of point A is 1. So on number line A is the point and its coordinate is 1. Now we have to construct here so that we will show this number on this number line. For that, draw a perpendicular line at A to this number line. This is a perpendicular line drawn at A to the number line. You can use to draw the perpendicular line, you use the set square which is in your compass box. Using set square you can draw this perpendicular line. Now on this perpendicular line take point O. On this perpendicular line, this is perpendicular line. On this line take point P such that distance of OA is equal to distance of AP. So here is point P. We have taken point P on this perpendicular line such that distance of AO is equal to distance of AP. And now join OP. So now here we get right angle triangle OAP. In this right angle triangle, OP is the hypotenuse, OA is the base, and AP is the height. So this distance is 1 unit. OA is equal to AP. This distance is 1 unit. So using Pythagoras theorem, you can find length OP. That means the hypotenuse of triangle OAP. So by Pythagoras theorem, now using Pythagoras theorem in triangle AOP, we will find the length of hypotenuse of this triangle AOP. So by Pythagoras theorem, OP square is equal to OA square plus AP square. Now if we put the value here OA is equal to 1 square plus AP is equal to 1 square. So we get 1 plus 1. Square of 1 is 1. So here 1 plus 1 is equal to 2. So OP square is equal to 2. So by taking square root of both sides, we get OP is equal to root 2. Taking the square root. Now that means this distance OP is root 2. This distance OP is root 2. Okay. Now we will take the same distance on this number line. The same distance we will take here on number line. Okay. So here is root 2. So on number line, this point is root 2. Let that point be Q. So in this way, we can show rational number on number line. Now, if we want to show minus 2 minus root 2 on number line, so minus root 2 will be on the left of the 0 at the same distance as OQ. So therefore we can take the same distance here on the left of 0. So here is suppose point R, and coordinate of this point R is minus root 2. In this way, we can show the irrational numbers on number line. Now here on page number 6, activity is there. You have to fill the empty boxes here. Figure is given. In the figure, length of OQ is equal to root 2 and length of QR is equal to 1, that is 1 unit. And OQR is right angle triangle. Using the Pythagoras theorem, you can find length OR. To find the length OR, you put the values in the formula. The formula is given, put the values in the boxes and find length OR. See here, by Pythagoras theorem, length of OR square is equal to length of OQ square plus length of QR square. Now, put the values here. OQ is given root 2, that means root 2 square plus QR is given 1, root 2 square plus 1 square. So you will get here root 2 square is equal to 2, 1 square is equal to 1. So 2 plus 1 is equal to 3. That means OR square is equal to 3. Take square root of both the sides. Therefore, length of OR is equal to root 3. In this way, you can fill the boxes here. And now, we have solved some examples from practice set. You solve remaining examples. That is your homework. And in next period, we will start next chapter, parallel lines and transversal.